Okay, if you're watching this video, it's because these radical things with addition and subtraction are driving you nuts a little bit. So let's see if we can figure them out here. We'll look at A and we'll look at B. A is the 8 root 2 plus 3 root 50 minus the square root of 45. So it requires to simplify these two radicals before we can do anything else. 8 root 2, nothing we can do there, because 2 is as small as you can get inside a radical. 3 root 50, well, I can say this is the square root of 25 times the square root of 2. And if you think back, if you remember back a little bit, what we're looking to do is pull out a 4, a 9, a 16, a 25, a 36, a 49, 49, and so on, right? 64, I keep going, 81, 100. One of these perfect squares, and 25 is the largest one that'll work there. 45, the largest perfect square that'll work is 9, so we can pull that one out. Minus 9 and 5, okay? And then we look and we say, oh, this is 8 root 2, nothing I can do there. Root 20, so this is plus 3 times 5 root 2. Root of 9 is 3 root 5. Okay. All right, so we just keep going. We kind of do what we can. 8 root 2. 3 times 5 is 15 root 2 minus 3 times 5. Right? 3 root 5. And then we say, hold on, we have like radicals right here. Okay, right there. So 8 plus 15 is 23 root 2. Because we can combine those same way we combine like terms, right? We talked about that in the last video. And minus 3 root 5. And we cannot combine these because this 2 and this 5 inside the root are not the same. So we're done, right? So you're like, yeah, it's simpler than that. It's still not really simple. It's still a bit of a mess, but that's as far as you can go. And then we're done with that one. Okay? Let's look at B. All right, I'm going to leave these up there. Let's find B here. All right, negative 7 cube root of 40. Negative 7 cube root of 40 plus the cube root of 5. Cube root of 5. Now, these are of no value at all because I'm not dealing in square roots anymore. I'm dealing in cube roots. So we're going to have to rub these things out. Okay. Is there a cube root that's going to work? So what are cube roots? Well, 2 times 2 times 2 is 8. So the cube root of 8 is one that'll work. The cube root of 27 is 3 times 3 times 3. The cube root of 64 is 4 times 4 times 4. And our numbers aren't any bigger than that. So if it's not one of those three, there's nothing we're going to be able to do here. And what I notice is for 40 can be divided by 8. So we can use that one, negative 7. And we have the cube root of 8. And 8 times 5. And the cube root of 5 plus the cube root of 5. Okay, so I'll give you a second to have a look at that. Now the cube root of 8, I'll come back, is 2. So I have negative 7 times 2 times the cube root of 5 plus the cube root of 5. All right? And negative 7 times 2 is negative 14. Cube root of 5 plus the cube root of 5. All right? So this is the same cube root, so we can add these. Remember, when there's nothing in front, us mathematicians don't bother with the 1. So it's really negative 14 cube root 5 plus 1 cube root 5. And negative 14 plus 1 is negative 13 cube root 5. Okay? And that's our answer. If we want to get it as a decimal, we'd have to take the cube root of 5 multiplied by negative 13 to get our decimal answer. But we leave it like this because it's precise. Okay? All right, we'll see you next time.